Hello and welcome to this video where I'm going to show you how to build a transactional Delta Lake on AWS S3 using Glue and Athena. Before we begin, let's quickly go over the definition of a Delta Lake. Basically, a Delta Lake is an open source software that extends Parquet files with a file-based transaction log for ACID transactions and scalable metadata handling. It's the basic foundation if you're building a lakehouse architecture. Now, for those who are curious as to what's a lakehouse is a modern data architecture that creates a single platform by combining the key benefits of data lakes and data warehouses both. And Delta tables or Delta storage tables act as the building blocks if you're building a lakehouse on AWS. With Spark or PySpark, which is going to be our focus, it's quite easy to use Delta Lake as the storage layer for writing and reading data as well. Typically, in most scenarios or use cases, we use a traditional data warehouse like Redshift or Snowflake, where we use a data integration tool to fetch the data from the source, let's say MySQL, PostgreSQL, or Oracle DB, and then we write it first into the raw layer inside a data warehouse. We then have further layers within the data warehouse, such as the curated layer, which will have combined or modeled data using one of the data modeling techniques. And finally, we have the presentation layer, which is the data that's exposed to the outside world in the form of BI. Now, depending on the nature of your business, each layer can serve its own purpose, which could be different. For example, a raw layer is mostly used for operational and ad hoc querying. The curated layer could be used for basic level reporting, and the presentation layer or the semantic layer is mainly used for advanced analytical reporting. With Delta Lake, we take the raw layer outside of the data warehouse and we build it on S3. Now, you can also build the other two layers using Delta Lake on S3. It's a common scenario and it totally depends on what you're trying to build here. With this approach, you have a more flexible architecture where you're not relying entirely on a data warehouse or its resources, as your transactional raw data is in S3 and only the curated and the semantic layers running on Redshift. In this tutorial, we will first set up a MySQL database on AWS RDS, which acts as the source of transactional data. We'll run a Python shell job then on AWS Glue, which will extract the data from MySQL and write it to S3, which is a raw landing zone. And keep in mind, this landing zone can potentially contain duplicate data, and it does not support ACID properties or transactions. As we set up this glue job, I will also show you how to handle incremental data loads from MySQL using DynamoDB, where we store the ETL metadata logs such as the last extracted value using table names and column names inside a DynamoDB table. Now, once the data is available in the landing zone in S3, we will set up another glue job, this time using PySpark, which will read this raw data from the landing zone and write it to a separate location in S3. This location can be a different folder in the same S3 bucket or a new bucket, it doesn't really matter. Now, the data written as a result of running the Spark job inside the Delta Lake location in S3 will not contain any duplicate rows. It'll be reliable. Most importantly, it'll be ACID compliant and cost effective as well, as the Delta format stores data as snappy compressed Parquet files, which we will see when we run the jobs. After this point, you can query this transactional data using Athena and crawlers, which we will cover in this tutorial as well. So let's begin with our lab. All right, so the first step is to set up a MySQL database on AWS RDS. So for that, go to your search bar and type RDS. Now from here, you can click on Create Database and select MySQL. You can leave the version as is, which is the latest version. And under Templates, make sure to select the free tier. Under DB Instance Identifier, you can give it a meaningful name like e-commerce -db underscore is not allowed. The username, I'm going to leave it to admin as is. And for the password, I'm going to enter my password. Make sure to remember this password or make a note of it because we'll be needing this every time we connect to the MySQL database using the terminal or even the Python script. Scroll further down. T3 micros sufficient, 20 GB is more than enough. 20 GB is the lowest you can go using the free tier. Make sure to change the public access to yes. I'm using the default VPC and the security groups. And that should be it. Now you can click on Create Database. I'm not going to do it because I've already created an instance. Once you click on it, it's going to take roughly 10 minutes or so, and you will have an instance up and running. Now, once you have the instance up and running, you can click on it. And the first thing that you got to do is change the inbound security group connections so that you're able to connect to this MySQL instance on port 3306, right? So scroll down under connectivity and security. You can click on the security group, click on the group ID, and select edit inbound rules. Now in here, in my case, the changes have already been done. In your case, you need to click on add rule. Under the type drop down, select MySQL Aurora, and you can see the port number automatically selects 3306. And for the source, you can select 0.0.0.0, which basically means you're granting access to this MySQL instance from across the globe, literally everywhere. You can also manually enter your own IP address. You can grab your IP address from Google by typing what's my IP and just allow access to that IP address. All right, but yeah, it was fine. Now I'm going to select cancel here because I've already added the rule on port 3306. So you can add the rule, click on save rules, and once you're done, you're good to go. So once we're done with this, the next step is to be able to connect to this MySQL instance. And we'll be doing that using the command MySQL followed by the endpoint URI followed by the port number, username, and password, which is the first command inside the file MySQL queries.sql. So I'm gonna grab this. By the way, you must change the endpoint URI, which is this one right here. You can grab the endpoint by going back to RDS and selecting your DB instance, and you can grab the endpoint from here. All right. So once you copy it, just make sure you replace the value here. So I'm gonna copy that. And before I run this command, I want to make sure that you guys have navigated to the folder where you have copied all the source files from my GitHub repo. All right. So if I do an ls, you will see all the necessary files are here. And this is important because this command to ingest the data, which is the third command in the file, expects the CSV file which contains the data to be ingested to be in the current working directory. Now, if that's not the case, you must type the absolute path as to where the CSV file resides. So I'm going to be running this from my current working directory. So let me run this. I'm going to enter the password. All right, so we have successfully connected to our MySQL instance. Now let's create a database. Create database. I'm going to call this ecom_db. Now I'm going to say use ecom_db. Now let's create the table. We're creating a table called orders, and this table is going to hold orders data from our fictional e-commerce website. So you can see it has the order ID, user ID, status, when was it shipped, when was it created, delivered, number of items in the order, and the last updated timestamp. So let's paste it here. All right, so the table has been created. You do a show tables. You should see a table inside the MySQL database. Now comes the data ingestion part. It's a simple command which loads the data from your local file orders-1804.csv into ecommerce_db.orders table. So let me grab this and run this. All right, so you can see roughly 1600 rows were ingested into this table. You can quickly do a select star from orders, limit 10, and there you go. So we have successfully set up a sample database in MySQL. Next up, we move on with a Glue job, which will connect to this MySQL database, extract the data, and write it to an S3 bucket. All right, now let's head over to AWS Glue by typing Glue in the search bar and selecting AWS Glue. Now let's select ETL jobs. Now I'm going to click on script editor and select Python shell because we're going to be setting up a simple Python job that'll extract data from MySQL and write it to S3. Let's click on create script. Now for the script, you can open up the file mysql extraction job.py. And the code is quite simple because it's pure and simple Python. So we start with the boilerplate import statements. And keep in mind, all these libraries come pre-installed in Python shell on AWS Glue. So you don't have to worry about installing any library. Then we define a database endpoint, which you can grab from your RDS dashboard under connectivity and security. This is your endpoint, so make sure to change it. That's your username, password, the name of your database, which we created inside the MySQL instance. This is my S3 bucket. So go ahead and create a bucket in case you don't have one, but make sure to change the value here. Inside this bucket, the output will be written inside a folder, raw landing zone, followed by orders, followed by data.json. So every time the script runs, the existing JSON file will be overwritten by the subsequent run or the next run, so that we don't need to keep an unnecessary copy of the historical data in the raw landing zone. Now comes the important part, where the script will talk to a DynamoDB table called ETL logs, which we will create shortly. And then it'll try to fetch the last extracted value and the filter column for that specific table. In this case, it's orders. Now, in case the last extracted value is not found, which will be the case for the first execution, it's going to assume a default value of 18th of April 2024. And this is the default value which we know exists in the MySQL DB because we ingested the data, right? And the last updated TS is going to be used in the filter conditions, which is right here. So it says select star from orders where filter column, which is your last updated TS, comes from DynamoDB, is greater than or equal to filter value, which is this one for the first run. And for the subsequent runs, it's going to fetch it from DynamoDB. Now, once the script executes successfully, meaning upon successfully writing the data to S3, it's going to invoke this function, which will ingest these attributes into the ETL logs table. So the table name is orders because we're running this pipeline for orders table. The filter column is last updated timestamp or TS. The last extracted value is the max value from the extracted data set. Okay. And the last run timestamp is basically the current timestamp of the execution time. Now, again, for subsequent runs, it's going to fetch the last extracted value and use it accordingly to incrementally extract data from MySQL DB. All right. So I hope it makes sense. The rest of the code is pretty much boilerplate. It's quite simple. You can go over it. Now, what we're going to do is basically copy the script and paste it here. Let me rename this job. I'm going to call this my SQL extraction job. For the job details, I'm going to select the IAM role, which I've created, custom Glue service role. Now, in case you do not have an IAM role created, you can type IAM from the search bar and open it in a new tab. Click on roles, click on create role, select Glue from the drop down, click on next. And this is where you attach the policies to this role. Now for the policies, I'm going to show you the policies that my role has. I'm not going to create a new role because I already have one. So let me go back to roles and find the custom Glue service role. So you need to attach 3 policies. Now you'll see more policies here because I use this role for several other purposes. First one is DynamoDB full access because it reads and writes into DynamoDB. The next is S3 full access. Again, it reads from it reads from MySQL and writes to S3, right? So you need S3 access. And then finally, you have the Glue service role. You don't need to attach the CloudWatch full access, I believe, because it comes with the basic CloudWatch access. The Glue service role comes with CloudWatch access. So attach these 3 permissions to your role and click on create. Once you're done creating the role, you can come back, click on this little refresh icon and select your role from the drop down. Now let's scroll further down. I'm going to set the timeout to 10 minutes, which is a lot. And that should be it. Now let's click on save. But before we run this job, we must create the DynamoDB table. So I'm going to select DynamoDB, click on create table, and I'm going to create a table called ETL logs. The partition key, I'm going to set this to table name, and that should be it. Let's click on create table. It's going to take a few seconds, shouldn't take too long. We don't need to worry about creating the attributes in this table because it'll be created dynamically by our Python script at runtime. Now let's go back to our Glue job and run it. So if you click on runs, you should be able to monitor the current execution. Now, as the data is not a lot, it's only 1600 rows. It shouldn't take more than 20 seconds, 15 seconds maybe. So let's see. All right, say succeeded. Let's go to S3 bucket, do a refresh, and there you go. So you have raw landing zone, orders, data.json. Also, let's go to DynamoDB and we click on this editor, PartiQL editor. Now we fire a query called select star from ETL logs. Let's say run, and you should see the values here. So this is the last extracted value. This is the table name. This is the last run timestamp, and this is the filter column used. So everything works as expected, right? Now the next step is to run the Spark job, which will create a Delta Lake inside a separate location in the same S3 bucket. For the Spark job, you can open up the file spark transactional delta lake.py, and the code is quite simple. It's barely 20 lines of code. So we begin by importing the Spark session and then the delta table because we're dealing with delta tables now, right? And the next few lines of code are quite important. This is something you don't see in a typical Spark job. So we set the app name, which is quite usual. And the next line says spark.sql.extension and sets the extension in order to use the delta lake or delta table extension. This is basically extending the features of your Spark job or PySpark job, allowing for delta lake extensions. Next, we set the catalog to delta catalog, which basically means this job is going to be using the delta catalog in order to manage the database and table metadata, which is extremely crucial for ACID transactions, right? The last line sets the retention policy to false, basically allowing for indefinite retention for historical data. And the rest of the code is a typical PySpark code. So this is our S3 bucket path where the input data resides, right? We have it in raw landing zone inside the subdirectory orders. This is an output path, which is going to be inside the same bucket. You can use a different bucket as well, but I'm creating a Delta Lake folder inside the same bucket inside the table orders because we're dealing with the orders table now. So we read the JSON file, which is the input of the previous job or the MySQL extraction job. And then we check if a Delta table already exists in the output path. Now for the first run, nothing's going to exist in the output path because we haven't executed this, in which case it's going to write the output in Delta format. Keep this in mind, in Delta format to the output path. All right. Now, in case the table exists, which is going to be the case for subsequent executions of the Spark job, it's going to do a merge or an upsert on the order ID because order ID is the unique identifier for the orders table. That's pretty much all there is to the Spark job. So we can copy this Spark job now. From ETL jobs, let's click on script editor. We select Spark, create script, and paste it here. Just make sure to change the S3 bucket name here. That's all you need to do. So I'm going to call this Spark Delta table. Now, before we execute this, there's one important step. We need to upload the jar file, which is crucial for the Spark job to write the output in the Delta format. So make sure to grab the jar file from my GitHub repo and upload it to your S3 bucket. So I'm going to go to the root of my S3 bucket, create a folder called jar, and upload the jar file over here. All right, now let's click on this jar file and grab its path. We come back, select the same IAM row, and this is quite important. Make sure to select Glue version 3.0 because 4.0 is not supported for Delta tables yet. The number of workers, I'm going to set it to 2 because that's the minimum. Job timeout, 10 minutes. Now let's expand advanced properties. Keep scrolling down, and under libraries, we paste the path of the jar file under Python library path and also under dependent jars path, right? I believe that should be it. Now let's click on save. Let's quickly go over the script. Everything looks fine. We can actually put the absolute path of the file here by saying data.json, or you can leave it as is. Uh, Either way, it's going to work. Now let's click on run. So I believe it's running now. Let's click on the runs tab. You can see the status says running. This job is going to take roughly 2 minutes. So I'll return once the execution is completed. All right, so the job has completed successfully. We can head over to S3, click on the labs or the S3 bucket, NL Labs AWS. You can see the folder Delta Lake, inside of which you will see orders, and there you go. So you have the Parquet file, which is compressed in snappy format, and then a folder called Delta Log. Now this is the folder which contains the metadata of your job, all right, which is quite important when it comes to using the other features of Delta tables, such as time travel and so forth. So that's that. Now, the whole point is to be able to query this Delta Lake or transactional data lake using an SQL editor, right? For which we're going to be using Athena. Now, for that, let's go back to Glue and find crawlers under data catalog. So here, I'm going to click on create crawler, and I'm going to call this orders crawler underscore v2 because I have already created the first one. Now let's click on next. Now we say add a data source, and under the data source dropdown, select Delta Lake, right? Now inside the path, we need to grab the absolute path of your orders subdirectory. So go inside the orders folder and click on copy S3 URI. Let's paste it here. Leave the option selected, which is create native tables, add Delta Lake. Now let's click on next. For the IAM role, I'm going to select the same role, which is custom glue service role. I'm going to say next. Choose a database. I'm going to select a database called e-commerce. Now, in case you do not have any database, click on add database and add the database here. So for example, ecom underscore v1 or whatever database you want to give, and click on create database here. So if you go back, click on this refresh icon, you should see your database here. The frequency on demand. I don't want to schedule it yet. Now let's click on next. Preview the options and click on create crawler. So the crawler has been created successfully. Now let's click on run crawler. Now the crawler is going to take a couple of minutes to finish its execution. I'll return once this is done. All right, so the crawler took roughly a minute to complete. Now you can type Athena in the search bar and select it. And inside the Athena editor, make sure to select the right database. In my case, it's ecom underscore v1. And if we select the, or if we run the query, select star from ecom underscore v1 dot orders, you should be able to see the data here. All right, there you go. So you have all the data as expected coming from MySQL from the Delta Lake. Now the next step, we are going to test the transactional Delta Lake by updating some data in the MySQL database and running the two jobs again. We're going to extract this data, only the updated data, and then run the Spark job and see if those updated rows reflect correctly in Athena. So now let's head over to the same script, MySQL queries.sql again. And in here, you will see an update query right at the end. Now, this query basically updates the orders table and updates three columns specifically. The last updated timestamp, which is set to the current timestamp, the delivered at column also set to the current timestamp, status set to complete, where status is equal to shipped. So basically for all the rows that have a status is equal to shipped, these three columns will be updated with these values. All right. So let's grab this query. I'm going to go back to my terminal and run it here. All right. So you can see 479 rows were updated. Now what's expected here? The expectation is that when we run the MySQL extraction job again, this job is going to extract only 479 rows because the last updated timestamp has been updated, right? And the Spark job on successful execution will update the Delta Lake for these 479 rows with these updated values, all right? And these updated values must reflect correctly when we run a query in Athena. So our database or the table inside the database has been updated. Now let's head over to Glue. Let me refresh. All right, so we have the two jobs here. I'm going to run the MySQL extraction job first. I don't need to set any incremental value. It's going to be fetched automatically from the DynamoDB table ETL logs. Let me say run now. All right, so the extraction is complete. Took 17 seconds. Now, if you go back to your S3 bucket, go to raw landing zone orders, and you see the size of this file or data.json. It's only 109 KB, which is relatively less compared to the previous file size, right? So you can assume this only has roughly 500 rows which were updated. Now let's run the Spark job again. So I'm going to go to Spark Delta table and click on run. As we know, the Spark job takes a little longer, which is roughly 2 minutes. I'm going to return once the execution is done. All right, so the Spark job took less than 2 minutes and it's done with the execution successfully. Now it's time to run the crawler and see if the updated rows reflect correctly in Athena. Now before we do that, let's go to Athena. And before you run the crawler, meaning before the data is updated, you might want to keep a track of what exists just to understand uh, which rows in your Delta Lake or on S3 have changed after the successful execution of the crawler, right? So for that, you can run a simple query, select status counter 1 from your table, which is ecom1.orders, and you will see the number of rows for each status. All right, this is before the execution of the crawler, meaning before the data has been updated in Athena. So what we did was basically updating all the rows which had a status is equal to shipped to status is equal to complete, right? Which means after the crawler runs successfully, there should be no rows with status shipped, correct? Now, before the execution, these are the values. So you can see there are 479 rows in the previous execution, which had a status is equal to shipped. All right, so just for something to keep in mind. Now we go back to crawlers and run it again. Now, while that runs, I'm going to open a new editor and run the same query. But let's wait for the crawler to finish its execution. I'll return once the execution is complete. All right, has begun now. All right, so the crawler is done with the execution. Now let's go back to Athena. And inside the new editor, I'm going to run the exact same query again. Let's run this. And there you go. This is expected. So only the rows which were updated in MySQL were updated in your Delta Lake as well, which is expected. So that's how you implement a lakehouse architecture on AWS using Delta Lakes using PySpark. So that's all for this tutorial. I hope you enjoyed it. Let me know in the comments if you have faced any issues or any questions at all pertaining to data lake or data in general. Thanks a lot for watching and do not forget to subscribe for more videos.